Welcome. This is Dennis Horowitz, president of Micronor Sensors. This product video provides a four-part overview of the MR387 series fiber optic e-stop system. Let's take a look at the three main components of this fiber optic sensor system. Welcome to the MR387 fiber optic emergency stop system. Let's take a look at the three main components of this fiber optic solution. First, we have the MR387 e-stop sensor. There are three versions. The MR387 with the duplex LC is selected for mounting on equipment cabinets, panels, or cabinet doors with the pigtail routing internally. The MR387 in IP housing is used where a turnkey solution is desired, which can be mounted inside an environmental protected cabinet to a panel or wall via the two flanges. Not shown is the MR388, which is the e-stop installed in a weather-resistant cabinet. Next is the MR380 controller. There's two versions of that as well. Both are universal for use with either multi-mode or single-mode fiber. The DIN rail mount module is the most popular, providing double pole, double throw relay contacts, as well as 5 24-volt status outputs. For embedding the fiber optic e-stop system into equipment, there's also the MR380-0 OEM controller with 5-volt logic output and open collector output. The third component is the fiber optic cabling that connects the e-stop to the controller. Here are three examples. This orange duplex LC cable signifies multi-mode. This yellow duplex LC cable signifies single mode. And the teal colored cable in our demo we'll talk about represents 50 micron multi-mode cable. And then here's an example of the IPLC connector, which makes connections to the IP housing unit. Let me demonstrate how the fiber optic e-stop system works. How does the fiber optic e-stop system work? First of all, it's a two-fiber system where light makes a round trip through the fiber loop. So we transmit light from the controller through the fiber, through the e-stop. The e-stop, when it's engaged, actually blocks the light, but in the reset position, light propagates through and to the receiver port of the controller. Here we have a little demo of how you might use the contacts of the controller in a working e-stop system. So what we have here is a 3-mode status display. So in the normal monitoring mode, the e-stop's in the up or reset position. We're displaying the green status connected to the normally closed contact outputs of the controller. And then we have, when I engage, I've actually used the normally open contacts, one to control the red status LED, and the other controls the siren. Just like you would normally use the contacts in an electromechanical e-stop system. But we can have this e-stop controller mounted remotely, and you could also have multiple controllers if you need contacts in other locations. Part 3. The MR387 fiber optic e-stop sensor system is very versatile. There are a number of ways to interconnect both single and multiple e-stop sensors and controllers to meet the safety signaling requirements of your application. Here is a basic single e-stop controller system. The dashed arrows show how light loops through the system in the normal monitoring state. Activating the e-stop or a broken fiber or a optical disconnect or loss of power, all of which interrupt the light path, trigger the emergency state. We can expand the single controller by connecting multiple e-stops in series. It is important to note that the total optical loss of the system, the sum of all e-stops, fiber segments, and each interconnect must not exceed the 23 dB optical loss budget of the MR380-1-3 DIN controller. Consult application note AN118 for guidance on calculating the optical loss of your proposed layout. There are different ways to arrange multiple e-stops and multiple remote controllers as required by the application. Using the standard MR380 controller, this linear layout is typically used when all controllers need to be co-located in the control room. One pole of contacts is wired in parallel. The corresponding controller visually identifies the e-stop group which triggered the event. Alternately, the TD5410 controller allows all e-stops and controllers to be wired in an optical loop, which logically latch when activated. This topology can significantly extend the reach of the e-stop system because every optical segment between adjacent controllers has its own 23 dB optical loss budget. After the activated e-stop is reset, applying 24 volts to the reset input of any TD5410 controller resets all of the controllers. Some applications require a local controller and one or more remote controllers. A simple method is to optically split the e-stop return path to control both local and remote MR380 controllers. Another method is to use loop controllers. Sometimes a multi-pole electromechanical e-stop is already installed. One pole is already directly connected to local safety equipment by using the second pole to control the 24-volt power input of the local MR380 controller. A remote controller can be optically connected to extend control to the remote location. Let's now go over how to specify and order MR387 system components. We are looking at the components of a typical fiber optic e-stop sensor link. On the right-hand side, we show the two types of MR387 e-stops. A duplex LC, pigtailed version, which would typically mount via a cutout hole on a panel or enclosure door with the fiber routed within. Or the flange mount, turnkey version with an IPLC connection. On the left-hand side, we show the three types of controllers. For embedded OEM applications, there is the board-level MR380-0-0 Uni controller. For industrial applications, there are two fully functional DIN rail mount controllers, the MR380-1-3 standard controller and the TD5410 loop controller. Here are some generic design guidelines. Which fiber to use? For distances less than 1,000 meters, most customers use multi-mode fiber, but single-mode fiber is okay. For longer distances, typically greater than 1,000 meters, most users will select single-mode fiber based on their existing long-haul communications network and installed fiber. But multi-mode is also okay. In this system, fiber selection is a little different because we're not transmitting data, which is where fiber selection is based on data rate, dispersion, and distance. This sensor system is based on an optical signal which is either on or off based on the e-stop state. Hence, the typical rules for fiber selection for data transmission don't apply. Which e-stop? Next, consider how you need to mount the e-stop. The pigtailed version
mounts through a cutout on the cabinet panel or door. The flange mount IP housing provides convenient mounting on a wall or panel. Which controller? If you need dry contact to emulate electromechanical switches, then select the DIN rail mount controller, which incorporate built-in double pole, double throw contacts. The three controller models and their internal functions are shown here. All controllers are universal, meaning they will operate with either single mode or multi-mode fiber. The board level MR380-0 is available for embedded applications. An open collector output can drive an external relay or solenoid. For multi-e-stop as well as multi-controller arrays, the DIN rail mount MR380-1 or TD5410 loop controller offer integrated double pole, double throw contacts. Now that the key decisions have been made, let's start with how to order an MR387 e-stop sensor. You simply need to specify the mounting style, fiber type, and pigtail length, if applicable. Mounting style is either the flange mount IP housing or the panel mount pigtailed version. This is specified here with D00 as for the IP housing and 1R5 or 03 or other pigtail length as required for the pigtailed version. For selecting the fiber, you simply select 2 for multi-mode or 3 for single mode. Commercial grade simplex or duplex zip cable is not outdoor rated. Pre-terminated lengths are typically installed in protective conduit. As a reminder, do you need shorter jumper cables to make the final connection to the controller, the e-stop sensor, or interconnections on a patch panel? All of these can be ordered from Micronor sensors. The Senko IPLC Plus connector and associated ruggedized cabling is ideal for harsh environments, whether indoors, outdoors, or exposed cable runs. The IPLC Plus connector features a sliding locking ring for security and to inhibit accidental disconnects. You can specify IPLC to IPLC jumper cables as well as IPLC to duplex LC breakout cables. We offer various bulkhead adapters for interconnecting different connector types. The MR320C bulkhead adapter is for joining 2 duplex LC plugs. For use with IPLC connections, the MR320D features IPLC on the outside and duplex LC on the inside. The MR320D inline is for interconnecting 2 IPLC plugs. Finally, there is the DIN rail mount 4-port duplex LC patch panel, which is ideal for defining a single point where multiple e-stop runs can be wired in series. Be sure to order simplex LC jumpers for the interconnections. Here is a real-world example of how these optical connectivity accessories can be used to facilitate a 2 e-stop multi-mode application. The remote e-stops are each connected to the control room via a long-length 100-meter multi-mode IPLC to IPLC extension cable. On the cabinet wall, 2 MR320D bulkhead adapters park the IPLC connections on the outside, and short duplex LC jumpers provide inside connection to the internal multi-port DIN rail patch panel. The 4-port DIN rail patch panel is used to wire the e-stops in series using short simplex LC jumpers. A short duplex LC jumper makes the final connection to the MR380 controller. These days, half of our customers seem to have a unique e-stop requirement based on the distances, the number of e-stops required, and the number of controllers needed to control remote equipment during an e-stop event. For small applications, standard e-stop products and cables are available from stock. You can also check pricing or purchase via the Micronor Sensors online store at www.micronor.com. If any questions or to request a quotation, please feel free to email us at sales@micronor.com or call me directly with technical questions.